Okay, I'm going to see how many I can get done in 15 minutes. So I took all the problems that you got wrong on the multiple choice, and I'll go through them. You can fast forward as needed. The position of a particle is given. What is the speed of the particle at the time t is equal to 3? Okay, I think this is just not realizing that I had given you these notes. Speed is the square root of the derivative of x at time t squared plus the derivative of y at time t squared. So I'm going to leave you with the answer as D, and I'm going to have you, if you got that one wrong, retry that on your own. All right, next, question 3. A polar curve is defined as such. K is a positive constant. For what value of k, if any, is the instantaneous rate of change of r with respect to theta equal to 15? All right, so we got a lot of things going on here. Instantaneous rate of change, that's our derivative. It's our derivative of r with respect to theta, so that's good. We don't have to make that into a rectangular polar equation. So dr d theta, k is a positive constant, so I can use my power rule there. So I have k times theta to the k minus 1 power plus 4 theta. All right, that's my derivative with respect to theta. When is the derivative equal to 15? And at the time theta is equal to pi. So I'm actually going to replace both of those things at one time. Okay, let's see how long this will take me. So let me bring up the calculator here. All right, so I'm not sure what calculator you have, but a TI-84 does this perfectly. All right, so I'm going to hit math, and I'm going to scroll to my solver function. Couple limitations with using an 84. First, the equation has to be set equal to 0, which isn't a big deal. So I'm going to say x times pi raised to the x minus 1, right? Because the calculator doesn't know the difference between the variable, plus 4 pi minus 15. So I'm just going to subtract 15 from both sides. You have to tell the calculator where to look. So if I'm looking at my multiple choice answers, everything is close to 1. I can keep it as 0. I can put it as 1. The biggest issue that students have, notice that the solve function is written in green. So you can't hit enter. Enter brings you down to the next line, and we don't have to change the boundaries. So I hit alpha, enter, and now the calculator has just solved the equation for me. So you could have done some guessing and checking with this. That's not really the intent, but you certainly, if you had the value of k, you could have plugged it into the derivative function, see which one gets you closest to 15. But that's, if you've never used the solver function on an 83 or 84, that's how you do it. Okay, so that gives us B as an answer. Oops. Okay, question 4. I was a little surprised at this one, but I think I know where the error would have occurred. So what's the area of just one petal? All right, so we find where our function is equal to 0. 0 pi 2 pi. So 0 pi over 7 and 2 pi over 7. Okay, so when we fill this chart out, okay, 0 is obviously going to give us 0. Pi over 7 is going to give us 0 as well. So if we think about tracing a petal, I start here at 0, 0. And then at pi over 7, I'm back to 0. So it actually traces this entire petal here. Okay, so I'm thinking maybe some people did the 2 times 1/2 here, but from 0 to pi over 7, one whole petal is drawn. So area is just 1/2, and this is calculator. if you got all this right, but you plugged it into your calculator incorrectly, then that's another discussion we can have. I'll look at what you plug in and we can figure out where the mistake came from there. All right, just simply plugging that into your calculator and you'll get the value of A. Okay, one petal, not the whole graph. If you took that and multiplied it by 7, obviously that is an issue, but we can talk about what you did specifically. All right, number 6, particle moves such that the position vector is given. What is the acceleration vector of the particle at time t is equal to 2? All right, acceleration is the second derivative of position. So if my position function is given, its first derivative, I need my product, first times the derivative of the second, plus second times the derivative of the first. I did factor out an e to the negative t here. I just think it simplifies the higher order derivatives, but that's my personal preference. So first times the derivative of the second, plus second times the derivative of the first. Okay, so then at time 2, I get negative e to the negative 2. Negative 2 plus 1 gives me negative 1, but times negative 1, it'll make that another plus, e to the negative 2. So this is nice and easy. This gives us an x coordinate of 0, so I can eliminate c and d. So y prime of t is 2 all over 2t plus 6. Write this as a power rule. So my acceleration would be negative 2 times 2t plus 6 to the negative 2 times 2. At time t is equal to 2, that would give me negative 4 over 100. So negative 4 over 100, that would make B my answer. What is the slope of the line tangent to the polar curve that's given at the point where theta equals pi over 4? Quite a bit of you got this wrong. 5 of you got this wrong, and 5 of you got number 4 wrong. I think the mistake here is that you didn't get the polar equation in terms, you didn't get an x and a y, right? So x is equal to r cosine theta, and our y is equal to r sine theta. So before you even found the derivative, we had to get x in terms of theta. So that would have been r cosine theta. And then y in terms of theta, given equation for r, times the sine of theta. So now when you go through and find the derivative, so now dx d theta, right, theta is your variable, first times the derivative of the second, plus second times the derivative of the first. And at this point, if you want to replace theta with pi over 4, so 4 times pi squared over 16 times negative root 2 over 2 plus root 2 over 2, 8 times pi over 4 would give you 2 pi. Let me come down here now. dy d theta, using product first, derivative of the second, plus second times the derivative of the first. So very similar looking derivatives. When theta equals pi over 4, pi squared over 16 times square root of 2 over 2 plus square root of 2 over 2 times 2 pi again. All right, just for the interest of time, I am going to have you complete it. Verify you can get C as an answer. All right, what's the slope of the tangent line? dy dx. All right, so take those. You'll need to get some common denominators and divide those, but verify that you can get C as the answer. All right, number 9. The graph is given. Which of the following expressions gives the area of the inner loop? Okay, so let's go with what we know. Set the equation equal to 0 so we can just get a general idea of what gets graphed. So pi over 6 and 5 pi over 6. Okay, looking good. I look at my boundaries, and my boundaries are pi over 6 and 5 pi over 6, so at least I know I'm on the right track. Theta r. So I'm going to go 0, pi over 6, pi over 2, 5 pi over 6, and then we'll stop at pi. Why did I pick that? Well, I see two answers have pi over 6 and 5 pi over 6 involved. I understand there's a negative pi over 2, but I'm going to go with what's seemingly a little bit more natural, using the values we find from setting r equal to 0. And if that can't help me, then we'll go back and look at the other bounds. All right, so sine of 0 is 0. That gives me 2. Sine of pi over 6 is a half. Half of 4 is 2, so that gives me 0. Pi over 2, 2 minus 4 gives me negative 2. At 5 pi over 6, it's also 0. And then at pi, it would be at 2. So, like I had said in class, more often than not, you're given the graph. So let's see what this looks like. Okay, so when theta is 0, my radius is out at 2. So that starts this point. At pi over 6, it brings me back to the polar axis. So now I've sketched that. Pi over 2 has a radius of negative 2, so that points down here. So now I would graph there. 5 pi over 6 brings me back to the pole. So what's the area of my inner loop there? Well, between pi over 6 and 5 pi over 6, that's how we drew that inner loop. That's how that inner loop was graphed. Okay. So the area of that part there, now so I can eliminate A and C, okay? 2 times, and then 2 minus 4 sine theta quantity squared, okay? Now, if I look at, so this was 2 times, so now look at my answer options, right? The 1/2 isn't out there. So if I look at factoring the 2 out and then squaring it, I would get an integrand of 4 times 1 minus 2 sine theta squared. Now 4 times 1/2 is where I get the answer of B and not D. Right, from pi over 6 to 5 pi over 6, it creates the whole loop. So I don't have to double that, but you do have to do a little bit more manipulating to see where the answer comes from. Okay, so again, this would be 4 times 1/2, and then 1 minus 2 sine theta squared. So I know I always bring the coefficients to the front of the integral, but we talk about even more often making sure you're understanding equivalent answers. All right, 10, 12, and then there's 4 problems for part A. So I'm going to stop here and I'll just create another video for the remaining problems, just so I'm not rushing through. Thank you.